Welcome. In this video, we are going to discuss about gas chromatography. Now, in gas chromatography, the mobile phase is a carrier gas. Okay, you use carrier gas as a mobile phase during gas chromatography. Now, the stationary phase used in gas chromatography can be a solid adsorbent or a liquid supported on an inert support. Okay, and if the stationary phase is the solid adsorbent, then that is known as gas solid chromatography, and if the stationary phase is a liquid which is supported on a matrix, then that serves as your gas liquid chromatography. Okay, so in gas solid chromatography, the stationary phase is solid, and in gas liquid chromatography, the stationary phase is liquid. Now, we usually call gas liquid chromatography as gas chromatography. Okay. Now, this gas chromatography, which is abbreviated as GC, is used to analyze the volatile substances present in the gas phase. Okay, so this gas chromatography is used for those analytes which are volatile and which are thermally stable as well. Okay, so if your analyte, okay, the substance that you have to analyze, that substance, if it is volatile and it is thermally stable, then you will use gas chromatography for its analysis. Now, this gas chromatography is the only chromatography that does not utilize the mobile phase for interacting with the analytes. Okay, there is no utilization of mobile phase in gas chromatography for interaction with analytes. Now, this GSC, that is gas solid chromatography, is based on solid stationary phase, and it involves the retention of analytes by physical adsorption. Okay, in GSC, the retention of analyte occurs because of physical adsorption. Now, there is this GLC, which stands for gas liquid chromatography. Now, in this GLC, the analytes are partitioned between the gaseous mobile phase and the liquid phase, which is immobilized on the surface of inert solid packing or walls of a capillary tube. Okay, so either there is a wall of capillary tube on which the liquid phase is immobilized, or there is a solid on whose inert surface is used for immobilization of the liquid phase. Okay, so in GLC, the analytes is partitioned between gaseous mobile phase and in liquid phase. Now, the mobile phase, which is involved in gas chromatography, is known as carrier gas, and there are different types of this carrier gas which are involved during gas chromatography. Now, this carrier gas must be dry. It should be free of oxygen and it should be chemically inert. Okay, helium, nitrogen, argon and hydrogen, okay, these are the example of generally used carrier gases. Now, which one of the gas is you are going to select for doing the gas chromatography, that choice depends upon the desired performance and the detector which you are using. Okay, so on the basis of the need of the desired performance and on the basis of the detector that you are using in gas chromatography, on these two bases, you decide which carrier gas you want to use for the experiment, for doing the gas chromatography. Now, these gases which we just talk about are available in pressurized tanks. So there are tanks of these gases which you can directly use in gas chromatography. Now, the pressure regulators are there, then gauges are there, and then there is flow meters. Okay, these things help us to control the flow rate of the gas. Okay, so this is how the diagram, the basic components of the gas chromatography looks like. Okay, there is a gas cylinder, and then there is this carrier gas controller. Okay, from here you are going to control the flow of the gas, and then there is this injection port into which you are going to inject your analytes, the substances that you want to analyze, and then this is your column. Okay, let's write it. Okay, so this is your column, and then this is your detector, and then you have a data processor as well. Okay, so this diagram represents the basic components of your gas chromatography. Now the carrier gas is passed through the sample ejection port, then it goes to the column, and then it goes to detector, and then at last it is purged outside. So this is how the flow of gas occurs. Okay, the flow of carrier gas takes place from sample injection port to column, then to detector. Now this sample ejection port, column and detector, these three things are held in independent isothermal ovens, and the various temperatures during gas chromatography is maintained in each part, and that depends upon the sample which is being analyzed. Okay, according to the requirement of the experiment, you maintain the temperature of the gas chromatography setup. Now the sample is introduced via this sample injection port. Okay, so we saw the sample injection port. Via that sample injection port, the sample is introduced. Now if you are using a liquid sample, or if your sample is in the solid state, then the chamber is heated to vaporize the sample. Okay, so in that chamber you vaporize your liquid sample or solid sample, and then it is injected into the system for gas chromatography. Now at last you saw a detector, right? Now what is the use of that detector? Well, that detector is used to detect the various eluting components. So the components which are coming out of the system, okay, that the study of that thing is done by this detector. So that's all for this video. Thanks for watching.